Okay, so we're going to look at different characteristics of quadratic functions today. So the first example, we want to graph the following function. We're going to label the vertex and the axis of symmetry. And we have f of x equals 1/2 times the quantity x plus 4 squared and then minus 2 on the outside. So if at first we don't really know about any of the formats, what would we do to graph this?
We observe the transformations and stuff.
Okay.
Figure out where the vertex would be.
Okay. We could do that. What does the transformation tell us?
Where the vertex is.
Okay. So then if we've got that plus 4 on the inside,
It's going to go to the left.
it's going to go left 4 and then down 2. Okay, so left 4 and down 2. Okay, and then what's the other thing we have to pay attention to?
Well, it's a quadratic function, so it's x plus 4 squared. Like whatever you were plugging for x, you would have to multiply by itself.
Okay. Multiply what by itself?
Oh, x plus 4, but
Okay.
never mind. I mean the 1/2 is it's a vertical shrink, right?
Okay, vertical shrink by 1/2, so we can apply that. So I would have to make sure that I would reference my original graph in order to do that. So I would have to look at these. What else could we do? Have we already figured out where the vertex is?
Yeah.
Okay, have we figured out the axis of symmetry? -4. Okay, so our vertex, let's go ahead and label that as -4, -2. Our axis of symmetry is here. And I'll put that axis of symmetry, which we will abbreviate AOS, and that's at x is equal to -4. Okay, so we could use the fact that we have a vertical shrink. Could we also make an XY table if we needed?
Yes. Yeah.
Okay. Which one do you want to do?
XY table.
You want to do the XY table? So what would be some good values we would want to try?
0, 1.
You want to do 0? Okay. If I plug in 0, I'm going to get 4. Squared is 16. Divided by 2 is 8. Minus 2 is 6. And that's okay. That's still on our graph. And if we know that 0 goes with 6, what other value can we get from that pretty easily?
-8.
-8 would also go to 6. We can just use the symmetry. Okay, and really how many points do we need to graph a parabola?
Just one more, right?
Well, as long as we have 3, but one of those has to be the, what? The vertex. One of them has to be the vertex. So this is enough.
1, 2.
Yeah, 2, at least 2 additional. And sorry, I drew mine a little bit pointy instead of curved. Okay, we want to make sure it's curved. Okay, so XY tables are always available. We did use the fact that we saw there was a horizontal shift and a vertical shift, and the fact that, again, we could have used the vertical shrink as well. So we pointed out that we have a vertex at -4, -2. And if you look into the form that's originally given, do we see those numbers anywhere?
Yes, we do.
Yes, we do. Okay, and that's because this particular form of a quadratic is called the vertex form. So the general equation of it, we would have f of x is equal to a times x minus h squared plus k. And when we have the vertex form, we know that the vertex is located at the point hk.
In the top, in the graph, isn't the equation f of x equals 1/2 x plus 4, not minus 4?
Yes, and so that's why in here it shows up as a minus, and then the vertex is the opposite sign. Yeah. Yes. So we use positive h, but it's a minus h in the form. Okay. Yes, Allison?
For the axis of symmetry, you say that x equals -4.
Mm-hmm.
Is that like the line?
No, it's the vertical line where the vertex occurs.
Oh, okay.
Okay. Which means it's the x coordinate of the vertex, right?
Yeah.
So we can state that the axis of symmetry is x equals h. Okay, and then there was that one more piece, the a. What did we say in the graph that we just did was 1/2. So what does that mean a represents?
1/3 or 1/2.
But in general,
Oh,
what is it?
Stretch or shrink.
It's a stretch or shrink. So it's a vertical stretch or shrink. Vertical stretch or shrink. Okay. Yes, Caroline.
Why, for the axis of symmetry, does it just say x equals h?
Because h is the x coordinate of the vertex. And the axis of symmetry is always going to be through the vertex, because that's the center point that splits it in half.
But, like, is it the x in
Bless you.
equation? Like, in the one that we just did, it was like x plus 4. But the axis of symmetry is -4.
Yeah. So remember, in the form, it's x minus h in here, because it's the opposite sign.
Oh, okay. So,
Wait, what does it mean by the stretch?
Vertical. It's the vertical stretch or shrink, because the a is on the outside of the square. Okay. Well, we also have standard form, which is f of x is equal to ax squared plus bx plus c. And we'll talk more about the standard form in a few minutes. And then our last form that we want to look at is the intercept form. And that is f of x is equal to a times x minus p times x minus q. And in this form, what happens is that the x-intercepts are p and q. Okay. Or the coordinates p0 and q0. All right. Yep.
what is p comma 0 and q comma 0?
The x-intercepts. So the x-intercepts are p and q, and then these are just the coordinates.
It's just showing that when it's p, then y is 0.
Okay.
Bless you. Okay, so let's look at standard form in more detail. So again, the standard form is the f of x is equal to ax squared plus bx plus c. Okay, So the axis of symmetry, again, occurs at the x value of the vertex. Does anybody remember how to solve for that? Yeah, what'd you get?
Is it that, like, x equals, like, the quadratic formula?
It's not the quadratic formula, but
Oh, it's
Ne-
the start with the D.
no, you were close. Negative b over
2a.
over 2a, yes. Axis of symmetry again. X is equal to negative b over 2a. All right. And if we recall, the vertex is always going to be on the axis of symmetry. So if you found the x value, how would you find the y value? You just plug it in. So the vertex will be negative b over 2a, and using our function notation, we plug in negative b over 2a into the function. And we get that coordinate.
Oh, so whatever you get for negative b over 2a, plug into the function.
Yep, and that's going to give you your y value. Okay, now maximums and minimums, it depends on the direction that the parabola is opening, right? If a is positive, which way does it open? Opens upward. And if it opens upward, we have this value down here. It has to be a minimum. And in the other direction, if a is negative, what's that?
So when a is greater than 0, there's a minimum.
Yes, because the parabola will open upward. And if a is negative or less than 0, that means it opens downward. And instead of a minimum, we have a maximum. And that maximum occurs at the vertex, or the y value. So f of negative b over 2a is going to be your maximum or minimum. Yes?
Why is the F on the outside?
It's the function notation, because you have to plug in the x coordinate into the function to solve for the y. Okay. So the last thing, what does it mean to be a y-intercept?
When x is 0.
When x is 0. Well, what happens when you plug in 0 for x when you're in standard form? What are you going to get?
0.
You'll have c left. You get 0 plus 0 plus c. So what does that make c? The y-intercept. Okay. And again, we find that because we plug in f of 0, and that's going to give us c. All right. We ready to try one? Yeah. Okay, so the one we're going to try is 1/2 x squared minus 4x minus 2. It's asking us to label the vertex, the axis of symmetry, and also describe the domain and the range. Alrighty, so where should we start? Find the axis of symmetry, exactly. So, my axis of symmetry, again, it's the x value of the center. So x is equal to negative b. What's my b value?
4, negative 4.
It's negative 4 is b, divided by 2 times, and what is my a value? 1/2. Okay, so I got a double negative up here. 2 divided by 2 is 1, so I have 4 divided by 1. My axis of symmetry is 4. So I'm going to go ahead and mark my axis of symmetry here. Bless you. Oh, I just realized. What did we also not mention about the A value up here? What was A in the vertex form? It's still the stretch and the shrink. Okay, still vertical stretch and shrink. So I'm going to put that up here. A is still the vertical stretch or shrink.
So when it's in this form, how do you know the horizontal structure?
We don't. We just, it's the, that A is on the outside. It occurs after the square happens. So all we can tell is that the horizontal stretch or shrink will be A. Just all we can tell, did I just say horizontal? All we can tell is that the vertical stretch will be A.
Oh, okay, so
Yeah.
we don't know.
No.
Okay.
Okay. Alrighty, so we've got our axis of symmetry, and what can I find from that? The vertex. So I'm going to plug 4 in. So f of 4 is equal to 1/2, 4 squared minus 4 times 4 minus 2. Okay, so I get 4 squared is 16 divided by 2 is 8 minus 16 minus 2. So I get -10, which means my vertex is located at -4, -10. Oh, sorry, +4, thank you. Okay, so +4, -10. All right, we've got we've got our vertex in, so we need at least one other pair of points using symmetry. What would be an easy one to plot? 0? Uh-huh. Well, remember, what did we say the C value is? Is the y-intercept. Yes, so I already see that my y-intercept is -2, so I can plot that. Using the symmetry, what other point will I have? 8, -2, exactly, just using the symmetry. Okay, so we will, let me see if I can curve this without it looking too pointed.
Wait, so when you plug in 8 for x, the y will be -2 as well?
Yes, if we plugged it in, but again, it's a parabola and it's symmetric, so we're just using the symmetry rather than spending time solving.
Yeah.
Okay, so I labeled my vertex, or sorry, my axis of symmetry already. My vertex is 4, -10. The other thing it asks for is the domain and range. What is our domain? Negative to positive infinity, and our range is -10 inclusive to infinity. Okay, so what do we think of that one?
That's very straightforward.
Yeah.
How did you get the 0, -2?
So remember, this value here is the y-intercept.
Oh, you just plugged it in.
Yeah. All right. Let's see. We've got, I'm just going to have you guys do this one here. So just like we did on the one we just worked together, make sure you graph it, label the axis of symmetry, the vertex, and describe the domain and range. Okay, so how did we do? Alrighty. Did we know in advance that this parabola would go downward?
Yes.
Yes, why?
Because it's -2.
Yes, our A value is negative. Okay, so kind of always pay attention to the little clues that you're given before you just plot it and walk away. Always look at that A value and consider, Is it positive or negative? That's one of the biggest clues as to the what your final graph will look like. Okay, the next one's a little bit different because now it's asking us to find the minimum value or maximum value of each function below. Okay. So finding the maximum or the minimum value. So whenever you're asked to find that, specifically the value, it's about the output, not the input. So that means we're interested in the y value of what? Where did we say maxes and mins occur? Of the vertex. So the y value of the vertex. Okay. Alrighty. So if we're given the equation in standard form, and we need to find the y value of the vertex, what are we going to have to find first? We have to find the axis of symmetry first, okay? Because we know that the vertex occurs on the axis of symmetry. Alrighty, so we said for the axis of symmetry, x is equal to negative b. What's my b value in the first one? 16 divided by 2, and what's my a value? 4. All right, so I get negative 16 divided by 8 is negative 2. All right, so again, that's going to be the x value of the vertex, so I'm going to plug that in now to find the y value. So f of negative 2 is equal to 4 times negative 2 squared plus 16 times negative 2 minus 3. Okay, negative 2 squared is positive 4. Positive 4 times positive 4 is 16. 16 times negative 2 is 32 minus 3, and we end up with negative 19. So when I go to answer this question, what is the minimum or maximum value? What do we know about this parabola? Does it open up or down?
It opens up.
It opens up. So I often will do a little sketch like that on the side just to remind myself it opens up. And if it opens up, what does that y value we just found? It has to be a minimum. So minimum of negative 19. Would I want to list the vertex to answer this question? No. No, because we're only after the outcome. And the outcome is negative 19. From this, could we describe the domain and range?
Yes.
Yeah, what's our domain? All real numbers, doesn't change. So I'll just say that. And what can we say about the range then?
Negative 19 common.
Negative 19 comma infinity, or y is greater than or equal to negative 19, because we know that it's a minimum value. Yes, Allison?
Will you ever tell us which way to do it on the test, the domain and range, or can we always do it in integral form?
Yeah, unless it specifies, then you can choose. Okay. Let's look at the next one. I've got negative x squared plus 5x plus 9. So again, what do we know about the direction of this parabola?
It opens down.
It's going to open downward, which means we are going to have a max. Okay, so just like we did in the previous one, find the axis of symmetry. So we get x is equal to negative, our b value is 5, divided by 2 times, what's my a value?
Negative 1.
Negative 1. Okay, so we have a negative 5 divided by negative 2. We're left with 5 halves. Okay, so we're going to plug that in, h of, I know, everybody's favorite fractions, right? So I have a negative. Does the negative get squared?
No.
No, that occurs after. So we have 5 halves squared plus 5 times 5 halves plus 9. Okay. We have to square both terms, so that's going to be 25 over 4 with a negative in front, plus 25 over 2 plus 9, and then what would I need from here?
Combine 25 over 4.
Well, you make us like term.
I need common
Common
denominator. Okay. So my least common multiple is going to be 4, so that's going to be 25 over 4. This will be 50 over 4. And how do we turn 9? 36 over 4. Okay. Add those terms together. We end up with 61 over 4.
Wait.
And so what's my answer?
Oh, yes.
Max is
Maximum
61
of
over
60.
Yes,
Would you want us to simplify that or just leave it as it is?
I would leave it.
Do you put values in fractions like that?
Yes. Okay. Alrighty. Domain, negative infinity to positive infinity, and what's my range?
negative infinity, comma 61 over 4.
Guys,
61 over 4, kind of negative. No. Oh, just kidding. No, just kidding.
yeah, because it's a max, so we're going downward. Okay. All right, what do we think of those?
Well, they're fine when they have good numbers.
I don't like
You didn't appreciate the fraction?
I like that all we have to do is find the root price.
Yeah, it's nice when you don't have to do a whole lot of extra. Okay. So vertex form, that was the very first one that we graphed. So let me rewrite that here. That was f of x is equal to a times x minus h squared plus k. Okay, and then again from that, the vertex is going to be the coordinate hk. Did the rules about our a value change?
No.
No. So again, if a is positive, we have a parabola that opens up, and therefore our vertex is a max or min? Min. So exactly the same. If a is negative, we open downward, and we know our vertex has to be a maximum. Okay. And what did we say about the axis of symmetry?
It's 8.
It's h. X is equal to h. And what is nice about this form? Do you have to solve for the max or the min? No. It's given to us. It's the k value.
Oh, because k is the y-intercept?
Is not the y-intercept, it's the y value of the vertex. Yep. Okay. All right. So we've already graphed one of those. So do you remember last class we did just the parent function of an x squared that didn't have a vertical or horizontal shift on it at all. It was still, the vertex was still at 0, 0, but we could tell that it had a stretch or a shrink on it, and we solved for that. So that's the same situation with this question here. Okay. We haven't, it's telling us to find the equation of the parabola that has a vertex of 2, 3, and then passes through the point 5, 1. Okay. Now, since it gave this to us, the vertex the place we would want to start with is the vertex form of the parabola. So our vertex form, we said, is f of x is equal to a times x minus h squared plus k. All right. Now, since I know what the vertex is, I'm going to go ahead and plug those in for my h and k. So that gives me f of x equals a times x minus 2 squared plus 3. And so since I know it goes through the point 5, 1, I'm going to replace my x and y with the coordinates 5, 1 and then solve for a. So my y value is 1. I get a. My x value is 5. So I'm going to get 5 minus 2 in there squared plus 3. And now I just need to solve for a. So if I subtract 3 from both sides, I get negative 2 is equal to 5 minus 2 is 3. 3 squared is 9. So what does that mean a must equal? Negative 2 ninths. Okay. All right, and now I'm just going to put all that back together. F of x is equal to negative 2 ninths x minus 2 squared plus 3.
Oh.
So we can tell that we have a parabola with a vertex at 2, 3, and it has a vertical stretch or shrink.
It has
Shrink of,
2
and it's also reflected
in the x-axis.
over x, exactly. Okay. All right, any questions on, yes?
So, how did you get the, how did x minus h turn into 5 minus 2?
Okay, so remember the vertex is 2, 3. So the 2 is here, and the 3 is here. Okay, and then we're given the point 5 and 1.
Oh.
So you see it?
Yeah.
Okay. All right, so this is our x, and this is our y. Yes?
Is the plus 3 without the vertical transformation up 3?
Oh, yes. Exactly. All right, so we're going to look at an application problem now. Alrighty, so the graph shows the parabolic path of a performer who is shot out of a cannon. Where? So y is equal to the height in feet, and x is the horizontal distance traveled. We want to find the exact height of the net when the performer lands 60 feet from the cannon. So again, our performer is being shot up in the air. What's her maximum height that she reaches?
60. Oh, 30.
She reaches a maximum height of 30 feet, which occurs at a horizontal distance of 25. Okay, and this is where she lands, and this is where the net is. And so that's what we're trying to figure out. What is the height of that net? Okay. Well, is it exactly 10?
Yes.
We don't know.
Because it's inclusive, so that isn't it a
Yes,
solid
but
dot, so-
yeah, but we can't tell exactly that it's exactly on 10. So we're going to have to solve. So again, we know what the vertex is, so it's just like we did before. F of x is equal to a times x minus, my x value of the vertex is 25, so I do minus 25 squared, and my y value is 30. So there's my k.
So you took the vertex.
Do we need to
and
plug in
hit-
0 and 20?
Yes, we're going to plug in 0, 20 because that's the value they gave us. Without them telling us, though, we really wouldn't be able to know. So they're telling us that it does go through 0, 20. So My y value will be 20. X value is 0. Okay, so if we start to simplify this, we get negative 10 is equal to negative 25 squared is 625 times a, which means a is equal to negative 10. Would this become a calculator problem?
Yeah.
Yes. Okay. All right, we can simplify this a little bit. So a is equal to, these are both divisible by 5. That becomes negative 2 over 125. Okay. So I have the equation now. The equation is f of x equals negative 2 over 125 times x minus 25 squared plus 30. But what is it I'm trying to find? The y when x is 60. So now I'm going to have to plug this in. F of 60 is equal to negative 2 over 125. 60 minus 25 squared plus 30. And as I said, this has become a calculator problem. The answer comes out to 10.4. Can I leave it like this?
So almost.
Yeah.
No.
What else do I need? I need my units. What's the unit?
High feet. Height.
Okay, so we can say the net is
10.4 feet.
10.4 feet. We'll just say high. Or off the ground. That's fine. So, was it 10 feet after all?
Almost. 0.4.
I do not know.
You didn't like that?
Basically 10.
I mean, if we used our calculator.
Yeah. Okay. So let's look at the last form that we haven't talked about yet. This is the intercept form. Let me rewrite that down here. Let's do this. Okay, so the intercept form. F of x is equal to a times x minus p times x minus q. All right, so as we said, the intercepts are going to be p and q, or if we write it as coordinates, they would be p0 and q0. All right. So let's just do a quick little visual here. Let's say I have a graph here, and let's say I have one of my x-intercepts at 1 and one of my x-intercepts at 5.
Oh, so your axis symmetry would be 1 plus 5 divided by 2.
Exactly.
So P plus Q.
Yes. Axis of symmetry will be x is equal to p plus q divided by 2. It does.
So it would be 3.
Yes. Okay, so do we have to memorize p plus q divided by 2?
No.
No. You can count, okay? It's the middle point between two values, which is always an average. So don't spend time, never spend time memorizing formulas you don't need to memorize. Stuff that you can figure out, you know, that's there. Okay. So again, that's the axis of symmetry, which is going to give us the x value. But I also want to find the vertex, so I need the
Y value.
y value. And we would find that by
Plugging in X.
plugging in x.
So
Okay. Or the axis of symmetry. So our vertex looks like p plus q divided by 2. And the y value would be f of p plus q divided by 2. And I know it doesn't look very nice, but again, I want you to get used to function notation.
So how would we plug in if it was 3?
Well, we'd need an equation.
So we would need like an A.
Yeah, we don't have that right now. Okay. Do the same rules for max and min apply?
Yes.
Yes, same rules. If a is greater than 0, it opens up, and we have a min. If a is less than 0, it opens down, and we get a max. Either way, those occur when we plug in f of p plus q over 2. No, I didn't need that last parentheses. Okay. Does A still represent the vertical stretch or shrink?
Yeah.
Yes, still does.
So if it's negative, we know that there's going to be a maximum.
Yes. Okay.
Then A is sad. And she makes a sad face. Yeah.
Who made a sad face?
A, if she gets less than 0 cookies.
Oh, well, yeah, that would make me sad too.
Yeah, exactly.
I got a sad face. If I got it.
Okay, so we're going to graph this one. What can we already tell by looking at the equation?
Wait.
It's going to open down.
Okay.
And have 2 x's.
We already know that it opens down. Yes.
There's going to be a max.
Okay.
There's going to be a max.
All right, so we already know it opens down. What are my x-intercepts?
-4.
Is it -4?
No, it's +4.
+4. Remember, it's attached. Yes, so it's the opposite sign. -2. Can we eyeball the axis of symmetry?
It's 1.
Okay, so we can actually eyeball this one, but I'm going to go ahead and solve for it, just so we remember. So P is 4, Q is -2 divided by 2. So we get 4 minus 2 is 2 divided by 2 is 1. But again, this one was pretty easy to eyeball. Alrighty, so finding the y value of the vertex by plugging in 1. So we get -1/3. We get 1 minus 4 times 1 plus 2. So that's -1/3 times -3 times +3. Double negatives cancel. 3's divide out. We're left with just 3. So where is my vertex located?
3. I mean, oh.
1, 3.
Wait, what? What just happened?
We plugged in 1.
How did you just get the 3? What happened to the negative?
Yeah, what happened?
There was a double negative here.
But why isn't it
-1/3.
negative to the other one?
Huh?
What happened to the other 3? That didn't have a negative.
It's just multiplying. So this is just multiplying -1/3 times -3 times +3. Don't distribute that negative sign. Okay. All right. Yeah. So yeah, double negative became positive, and then I divided that 3 by that 3. Okay. So vertex we just found at 1, 3. Does that make sense given what we'd already discussed about the direction of our parabola?
Ow. Yes.
Yeah, so again, always use those clues that are in there to make sure, because does it happen sometimes when you're solving over here that you make an arithmetic error?
Yes.
Yeah, so what if we had come up with 1 negative 3?
Then we would be like, wait, what?
Yes.
It needs a minimum.
Exactly.
It needs a maximum.
Yeah, so pay attention to those things when you're working on these so that you don't make one of those minor arithmetic errors that end up making the whole problem wrong. Okay.
The max would be 3, right?
Yes, so the max is 3. Alrighty, so again, we have a vertex here of 1, 3. We have an axis of symmetry here of x equals 1. Oh, and our x-intercepts, we have 4, 0, and we have negative 2, 0. Okay. Didn't ask for it here, but I think you guys got that down. Okay, so how about, let's see, how about you guys just do this one here, and then we'll run through our last couple.
We have more types.
What's that?
We have like more types of things.
The equation from a graph is all that's left.
Yeah.
Okay, so there is that example, and we just have a couple quick ones I want to run through real quick. This again is writing the equation from the graph, okay? So in this first one here, we notice that we have x-intercepts that are pretty nicely marked.
Oh, that's helpful.
Okay. We have a vertex that's pretty nicely marked. Okay. So we actually have two options for finding the equation of this one. We could use the vertex form or we could use the intercept form.
Let's use the vertex.
Actually, I'm going to go ahead and use intercept on this one. Okay. There's a reason. There is a reason. So f of x is equal to a times x minus, what's my first vertex? Or sorry, x-intercept I should say, 0, times x minus, what's my other one?
2.
Is 2.
There's 2 vertexes?
No, I meant to say intercepts, x-intercepts. Okay, so now that I have plugged those in, I need to plug another point in so that I can find A, but I don't want to plug in the intercepts that I just used. So now I'm going to use the vertex. Okay, so the y value is
-2.
-2 is equal to A. What's my x value?
1.
1. So I'm going to get 1 minus 0 and 1 minus 2. So this is -2 is equal to A times 1 times -1, so it's negative A. So A is equal to 2. And there is our equation. Do I have to put that minus 0?
No.
I do not.
Unnecessary.
Do I even need the parentheses around that first x?
I don't know.
No, I don't. This can be simply written as 2x times x minus 2.
Are we allowed to write it with like the extra 0? Just
That's gonna confuse
You are allowed to, but keep in mind, is this still vertex, not vertex, is this still intercept form?
Yes.
It is.
I wouldn't notice that at first.
Okay. Well, you want to pay attention to the fact that you do have an x outside, and then you have an x attached to something on the inside. So pay attention to those things. This is vertex form. It just means that it's understood that the first one is 0, x minus 0.
She keeps me.
Distribute.
Yes, you could. Yeah, if you distributed, you would get 2x squared minus 2x, which would become what form? Not slope, no. Standard. It would become standard form with a c value of 0. Okay, here is the reason I didn't want to use vertex form on that previous one, because look at this one. Can we do intercept form on this one?
Yes.
No. Oh, well, you want us to.
Yeah, we don't have intercepts on this one. So therefore, what are we going to have to use? Vertex form on this one. So f of x is equal to, I don't know what a is, x minus, what's my vertex here?
Oh, it's like H.
It's
negative 1, negative 2.
Negative 1, negative 2. So what's my h value then?
It is going to be negative
1.
2.
1.
I don't know.
The x value, opposite sign,
plus 1
and then
minus 2.
minus 2.
Why is it plus 1 and not minus 1?
Because it's the opposite, because it's horizontal.
Yes, when it's on, yeah, when it's on x, opposite.
Wait, why is it plus 1?
Because our vertex, the x value is negative 1. So therefore, it's remember, it's the opposite when it's attached to x. X's are complicated. Okay.
Oh, because that's X. So in this case, X has to equal negative 1.
Yes.
That makes sense.
Okay, so now I need to find another point that's on the graph, but not the vertex. And we actually,
Negative 4, 0.
yeah, this one is pretty clear here. Okay, so we're going to have y is equal to negative 4 equals a times 0 plus 1 squared minus 2. I'm going to add the 2 to both sides. That gives me negative 2 is equal to 1 squared is 1, which is a. What is a?
Negative 2.
Negative 2. So,
Why are we doing negative 4? 0?
yes, because of this point here. Okay, so f of x is equal to negative 2 times x plus 1 squared minus 2. I have 1 minute left according to my
What does A mean again?
A is the, yes, it's the vertical stretch or shrink, exactly.
So could you
Okay.
technically draw the parent function on the graph and then compare them?
You could if you had nice clear values.
Just a visual.
Yeah, but sometimes it's not so clear.